Hello learners, welcome to my YouTube channel again, that is Math Chemistry. We were doing the topic of Form 4, and in our previous lesson we talked about comparing the strengths of acid and bases. So today we continue from there, that is lesson 2. In comparing the strengths of acid and bases, we have said that 4 factors affect the strengths of acid and bases. One we have discussed in the previous lesson, that was degree of dissociation. We talk about strength acid, strong acid, weak acid, strong base, weak base, on their ability to dissociate in water, on their ability to dissolve in water. Today here we have pH, that is for our lesson 2. Now pH, what is pH? I think we have seen pH right from Form 1 in the topic of acid, base, and indicator. So pH is a scale that shows the acidity and alkalinity of a substance. It shows the acidity or alkalinity of a substance. And then the pH scale, it ranges between 0 to 14. Is a pH that range from 0 to 14. From pH of 1 to 3.5, it is a strong acid. From pH of 4 to 6.5 is a weak acid. pH of 7 is a neutral. pH of 7.5 to 10.5 is a weak base. pH of 11 to 14 is a strong base. That is now the pH. This is a scale that we use to test, that shows the acidity and alkalinity of substance. It shows now the strength of acid that we have. It shows the strength of the bases. Is the base strong or weak? Is the acid strong or weak? Now, if we see the acidity, always acidity of a substance depend on the concentration of hydrogen ion. Always, if we have acid, we normally take the amount of hydrogen ion present. Hydrogen ion, the concentration of hydrogen ion is what determines an acid. What make an acid to have the property of acidity is due to presence of hydrogen ion. So acidity depends on the concentration of hydrogen ion in solutions. Hence, strong acid has a higher concentration of hydrogen ion, while weak acid has a lower concentration of hydrogen ion. Here we have a strong acid, here we have a weak acid. Acidity, what determines it is the presence of hydrogen ion, but the one that is strong and the one that is weak, it depends on the hydrogen ion that we have. If it has high concentration of hydrogen ion, it is a strong acid. If it has a lower concentration of hydrogen ion, it is weak acid. Then let's come to alkalinity. Alkalinity depends on the concentration of hydroxide ion. If we talk about a base, we talk about hydrogen ion. It depends on hydroxide ions that we have for a base. Acid depends on the presence of hydrogen ion, that's for acidity. The alkalinity depends on the presence of hydroxide ion in solution. Hence, strong base has a higher concentration of hydroxide ion, while weak base has a lower concentration of hydroxide ion. Here we have a weak base, and here we have a strong base. What make them different is the amount of hydroxide ion that we have. If we see a strong base, it has a higher concentration of hydroxide ion. If we have weak base, it has a higher concentration of it has a lower concentration of hydroxide ion. Secondly, let's look now on electrical conductivity. How does electrical conductivity determine the strength of acid and bases that we have? The electrical conductivity of an electrolyte depends on the amount of ions in solution. This can be compared using, we normally compare the electrical conductivity of ions or of the substances by two things. One, by using an ammeter, or by determining on the brightness of the bulb. When we have an ammeter, so how can we use the deflection on ammeter to determine if the acid is strong or if the acid is weak? If we have a strong acids and strong bases causes a greater deflection on the ammeter, meaning we are going to have high deflection on the ammeter. If you have high deflection on the emitter, it means they are a strong electrolyte, hence ionizes fully to yield many ions. It is strong or it is strong acid or a strong base, and they cause a high deflection on the emitter. Why? Because they are a strong electrolyte, hence they ionize fully to yield many ions. What about weak acid and weak base? They cause a lesser deflection on the emitter, meaning the number of deflection that you are going to have on the emitter is going to be low. What is the reason? They are weak electrolyte, hence they produces less ions. The less ion produced, it causes a less deflection on the emitter. Next, let's go to what is affected by the amount of deflection on the emitter. Let's go to the next now. What affects now the electrical conductivity? Another one that affects is the amount of brightness on a bulb. How can we use now a bulb to determine if the acid or a base that we have is strong or the acid or the base that we have is weak? A strong acid and a strong base produces a brighter bulb, meaning the bulb that they produce, it is bright. What is the reason for that one? They are a strong electrolyte. Strong acid or a strong base, they are a strong electrolyte. Hence, they fully ionize to produce many ions. The many ion produced is the one that causes now the brightness of the bulb. What about weak acid and weak base? They produce a dim light. They produce a dim light. Why? They are weak electrolyte that they partially ionized, producing less ions. And that is now the electrical conductivity that we have. For the other one that determine now the strength of acid and bases is chemical reactions. The rate of chemical reaction depends on the amount of hydrogen ions in solution. The difference is the rate of chemical reaction depend on amount of gas produced or the rate of effervescence that we have. Let's say we have a metal, it reacting with a strong acid, or we have a metal, it reacting with a weak acid, So from now chemical reaction, how can we know if the acid that we have or the base that we have is strong or if it is weak? If we have a chemical reaction, it depends on the amount of gas produced. Whenever a metal reacts with a strong acid, we are going to produce salt plus hydrogen gas. Salt plus hydrogen gas. If we have metal and weak acid, the same, we produce salt plus hydrogen gas. Now, what is the difference that we have? For a strong acid, this one, it produces a higher number of hydrogen ion, meaning the production of hydrogen ion here is going to be high. That's why we talk about now the rate of effervescence, because effervescence comes due to production of a gas. So we can say the rate of effervescence that we have in strong acid, it is high, or we can talk about we have a rapid effervescence. Why? Because this is a strong acid. So whenever you see effervescence or the amount of gas produced, if it is high, we know that is a strong acid. What about a weak acid? The weak acid, we said that the amount of gas produced or the effervescence that is produced, it is low. So if we see a low gas produced or low amount of gas is produced, or the rate of production of the gas is low, we know that now the acid that we have, it is weak. And that is how the chemical reaction determine the amount, the strength of acid and bases that we have. Then let's go now to some examples that we have here. Let's consider this question. We use now from pH, also from chemical reaction, to determine now the equation. In an experiment, a student tested the values of various solutions and recorded the results as shown in the table below. We have solution A, which have pH of 8. We have solution B, which have pH of solution A, pH of 7. Solution B, pH of 8. Solution C, pH of 13. Solution D, pH of 5, and solution E, pH of 1. So we have question A here. Classify each solution based on its strength. We want to say now each solution A, B, C, D, E, the strengths that they have. So here we have a question coming now from the pH. How does pH determine the strength of acid that we have? So I think we have discussed about the pH. We say the pH value, this is a scale that runs from 0 to 14. So it shows us if we have a strong acid or we have weak acid. Or it shows if we have a strong base, or it shows us if we have weak base. So strong acid, it has pH range where from 0 to about 3, that is for the strong acid. For weak acid, we can say from pH of 4 to about 6. What is a strong base? A strong base, it can have pH of 12 to about 14. What about weak base? It can have pH of 8 to about 11. That is now. And we have the pH of 7, and that is for the neutral substance. That's now the pH, how it range. How determine now the strength of acid or weak acid, or how does it determine now the strength of the bases that we have. Let's see now our question A here. Classify each solution based on its strengths. What is solution A? A, it has pH of 7. What is the pH of 7? This is a neutral. So we talk about this one is a neutral. Then let's have B. B, it has pH of what? pH of 8. What range between pH of 8? pH of 8 to 11, this is a weak base. So the strength that we have here, we can talk about this weak base. Let's go to C. C, it has pH of 13. Where does pH of 13 lies? From 12 to 14. What does it have here? This is a strong base. So we can talk about here, solution C is a strong base. Let's go to question D. Question D, it has pH of 5. What range is the pH of 5? From pH of 4 to 6 is a weak acid. So we can take the strength that we have here is a weak acid. Let's talk about question E. Question E, it has pH of 1. Then what has pH of 1? From pH of 0 to 3, that is a strong acid. So our strength here, we can talk as a strong acid. Next, let's go to question B. Compare the electrical conductivity of solution B and solution C. What do you have about solution? Compare the electrical conductivity of solution B and C. B is 8, C is 13. This 13, D, it is a weak acid. No, is a strong base, while B is a weak base. Between strong base and a weak base, which one has high conductivity of electricity? We are talking about now the conductivity of electricity. The stronger, the higher the conductivity of electricity that we have. So here, which one is strong? C, it is stronger than the B. So which one has higher? Which one has a better conductivity? C is a better conductor than B. Why? What is the reason? C is a strong base, hence ionizes fully in water to release many hydroxyl ion than B, thus better conductor. So meaning C is a better conductor of electricity than the B. Why? Because this one, B is a strong base, it fully ionizes in water to produce many hydroxide ion. Question C, compare the volume of gas produced when marble chips, this one it is calcium carbonate. Calcium carbonate we refer as marble chips. So compare the volume of gas produced when marble chips are put into separate test tubes of solution D and E. We have solution D, that is what? A weak acid. Solution E, that is a strong acid. So we want to say now the amount of gas produced. So here we're using now the concept of chemical reaction, because chemical reaction, we say, is a reaction that shows the strengths that we have. E produces more volume of carbon dioxide than D. This E, if it reacts with calcium carbonate, it will produce more volume of carbon dioxide or more effervescence than D. Why? What is the reason? This is because E is a strong acid, hence fully ionizes to give many hydrogen ions, which will react with calcium carbonate to form more volume. That is now the reason that we have. Why? Because E is a strong acid. So the stronger the acid, the higher the amount of gas produced and the higher the rate of evaporation that we have. Question D. Which substance is likely to be pure water? Always pure water contain pH of 7. Which substance? Substance A can be pure water. Sodium hydroxide, always base of group 1 element, that is sodium and potassium, they are strong base. So which substance can show? That is C. What about ammonia? Ammonia is a weak base. Which solution has a weak base to here? Solution B, that it has pH of 8. We have solution B. Let's go to next, learners. Next we have now another question here. Explain the difference in a meta reading of the solution below. We have solution of sulfuric acid and we have ethanoic acid. Are you getting? So we want to see now, because we say electrical conductivity depend on two things: either the amount of deflection that we have on the emitter, or it depend the brightness of bulb that we have. So in this question, let's explain now the difference that we have. Why here sulfuric acid has a high amount of deflection on the emitter reading, while here ethanoic acid has a low amount of deflection on the emitter. Remember this one now. What have you said about strong acid and bases? We say strong acid and bases, they have a greater deflection on the emitter. What was our reason, if you remember? Because these are strong electrolyte, hence they ionize fully to yield many ions. So this one here is sulfuric acid has a higher deflection than ethanoic acid. I can refer answer here. I can say sulfuric 6 acid has a higher deflection, than ethanoic acid, ethanoic acid. What is our reason for this one now? What is the reason can we give here? Sulfuric acid is a strong acid, hence it ionizes fully to produce many ions than ethanoic acid, which is a weaker acid. So our reason here we can give sulfuric 6 acid. If we have sulfuric 6 acid, it is sulfuric acid that we have, it is strong acid, thus ionizes fully to produce many ions, or to form many ions, or more ions, to produce more ions. And that is the reason why we have a higher emitter reading in sulfuric 6 acid than ethanoic acid, because sulfuric 6 acid is a strong acid, it has a higher deflection of the emitter. Ethanoic acid, this is a weak acid, it has a lower deflection on the emitter. Let's say now another question here. Distinguish between each of the following terms: dilute acid and concentrated acid. This is a common question that normally the student will confuse here. What is a strong acid and a strong base? Weak acid. What is a strong base or weak base? With dilute acid. Here we have dilute acid and we have concentrated acid. So there is a great difference there. Dilute acids are acids that contain fewer number of acid molecules. Why? Because dilute the acid, it has been added with a lot of water. There is a lot of water that has been added. So the number of acid that we have in dilute acid, it is very low. We have fewer number of acid. While concentrated acid, these are acids that contain a larger number of acid molecules. Why? Because there is no water that is added to it. So dilute acid, they contain fewer number of acid molecules, while concentrated acid, they contain a larger molecule of acid. Let's differentiate between a base and alkali. Base and alkali, they are same. So what is their difference? A base is a substance that when dissolved in water dissociates to produce hydroxide ion as the only negative charge ion, while alkali are bases which are soluble in water. So base, that is for the general term. But if we come to alkali, alkali is a base. What is base? This is a base which is soluble in water. I get it. And the example will be that is alkali metal. Group 1 element, they are an alkali. That is why we call alkali metals. They form a base which is soluble in water. And lastly, define the term basicity of an acid. Basicity refers to the number of replaceable hydrogen ions in an acid. Example, monobasic or dibasic acid. Replaceable, the number of replaceable hydrogen ion. Let's say here I have nitric 5 acid. How many replaceable hydrogen ion that it has? It is 1. So it is basicity, it is mono. If I have sulfuric 6 acid, it has how many number of replaceable hydrogen ion? It has 2 number of replaceable hydrogen ion. I can refer as dibasic acid. So basicity, this is a term that is used to refer to the acid, meaning the number of replaceable hydrogen ions that we have in an acid. That is for our lesson for today. Welcome learners. Make sure you subscribe to the channel, you like it, you comment it, and also you share it to your friends so that we benefit all. Here we have self-trial question. Try to do this question and question 2 and share the answer on the comment section. Welcome.